Hello students, welcome back. Today we'll continue with exercise 7. Okay, in our last video we have selected some sums and I had given you for yourself. I have given you hint about each and sum. We have solved 9 to 10 sums, right? Today also I am not going to solve any sum completely. Okay, I am only going to give you hint. So again I had randomly selected some questions of exercise 7. Okay, so I will give you hint for each and every questions that you see on the board, right? And you have to complete it by your own. If you face any difficulty, then just mention in the comment section. Okay, so let's start with question number 29. Okay, see, question number 29. It's 0 to 1 dx upon square root of 1 plus x minus root x. Clear? So you might be thinking here to use the property like a plus b minus x, 0 plus 1 minus x. Then this will be 1 plus 1 minus x, so 2 minus x. And this will be 1 minus x. So you will not get the same denominator, right? So we cannot use here that property, right? It will be very difficult to use that property and solve this sum. You can see here in this type of sum, if let's say it was not integration, then what we are going to do? We are going to do multiply divided by conjugate. So first let's only this much and then integrate it. So what we can do, we can here multiply it by conjugate and divide it by the conjugate. See now what I have done? I have multiplied it and divided it by the conjugate. So what will be in the numerator? Root of 1 plus x plus root x. But when you check the denominator, a minus b, a plus b. So a square minus b square. So what is a square? Square of square root of 1 plus x minus this. It's 1. Right? Now you can easily solve this. This power 1 by 2, this power 1 by 2. So 1 plus x is to 1 by 2 plus 1 upon 1 by 2 plus 1. X 1 by 2 plus 1 upon 1 by 2 plus 1. And then put the higher limit minus lower limit. Okay? And then solve this sum completely. Clear? So this by this way you have to solve question number 29 multiply divided by conjugate. Clear? Now let's see the next sum. Next is question number 31. 0 to students check the numbers are randomly, okay? It's not in sequence. The remaining sums, right? The sums which are remaining in between, that is solved in the next video. So 0 to pi by 2 sine 2x tan inverse sin x dx. Okay, so definitely you will get a hint that you can assume sin x as t, right? So if you are assuming sin x as t, what is its derivative? Cos x dx. We are not having cos x, but sin 2x, we can split this. What is sin 2x? 2 sin x cos x and tan inverse sin x dx. Now you can assume it like let sin x equal to d. So what does this imply? Cos x dx equal to dd. Clear? Now you also need to change the lower and upper limit. When x is equal to 0, sin 0, t is equal to 0. When x is equal to pi by 2, sin pi by 2, its value is 1. So now our integral will be 0 to 1. 2 its constant, I can take it out. Instead of sin x t cos x dx dt tan inverse sin x of t. Now this is your integration, right? How will you solve it? Integration by parts. U V, right? Light. Logarithmic inverse trigonometric, algebraic. So then it's algebraic. So U V, you can solve it by integration of by parts and then put the upper limit and lower limit, right? If you're finding difficult in this type of sums, then refer exercise 7.6. We have solved this type of sum in exercise 7.6. The only thing you have to add here is put the upper limit and lower limit, right? Now, no need to replace this value sin x again. Okay, solve it by parts and then put upper limit 1 minus the lower limit 2. Okay, so you have to solve by this way question number 31. Rearrange and assume sin x equal to t. Clear? So this was about 31. Now let's go to the next one. The next sum is 34. Okay, so just think how we can solve it? We can assume it integration by parts, integration by partial fraction. Okay, here there is no trigonometric function. We cannot use assumption, no fx, f dash x, but integration by partial fraction, right? X square, x plus 1, second degree polynomial, right? So how we can do here? 1 upon x square x plus 1 a upon x repeated, okay, plus b upon x square, right? Repeated factors. We were using this in repeated factors, okay, but till now we have only had the sum like x plus 1 whole square, x minus 3 whole square. There is only x square. We can consider it as like x plus 0 whole square. So plus c x plus 1, right? So 1 will be equal to x, x is there, so eliminate that, b c x square, right? So take value of x as 0, you will get the value of b. Clear? Take the value of x as minus 1, you will get some equation like a plus c equal to this. Okay, take another value plus 1, right? You will get equation in form of a, b, c, put the value of a, right? And you also have one equation about a and c, and this another, use the elimination method and find a and c. Or else, use the comparison, right? Compare the coefficient of x square, here it is 0, right? And here the coefficient of x square is c. So you can solve it in that way. Clear? So that was about question 34. And finally you have to integrate it. Okay? Let's move to the next sum. Question number 35. Okay, question number 35. 0 to 1 x e raised to x dx. Okay, so it's easy integration by parts. Take this as u, this as v. Clear? X as it is, integration of e raised to x minus integration of derivative of u, integration of e raised to x, and then solve it. Finally, put the upper limit and lower limit, right? So it's very simple sum. Let's move to the next one. Question 36. X raised to 17 cos raised to 4x dx. Okay, now see here, it's minus 1 and 1. So when it is like this, you just have to think like minus a to a, right? What type of properties were there, right? You were checking whether it is an odd function or even function. If it was an even function, then it is 2 times 0 to a. And if it is an odd function, it will be 0, right? So here the function fx is equal to x raised to 17 cos raised to 4x. So let's take minus x. Minus x raised to 17 means minus x raised to 17. And cos raised to 4 into minus x, as it is the fourth power. And also cos is an even function. So it will be positive only. See here, fx is equal to f of minus x. Right? Fx, sorry, this is equal to minus fx. Right? Both are not same. So f of minus x is equal to minus fx. So it is an odd function. So your answer will be equal to 0. Clear? Okay, so this was question number 36. Let's move to the next one. Question 37. 0 to pi by 2 sine cube x dx, right? Now remember, in indefinite integration, we had already done this type of sum. If it was only sine, we'll use direct integration. Integration of sine is minus cos. If it was sine square, then we will convert it into 1 minus cos 2x by 2. Now, if it is sine cube x, then we were using the property of sine 3x. See, sine 3x, the formula is 3 sine x minus 4 sine cube x. We just need to separate this sine cube x. It will be sine 3x minus 3 sine x. Or let's take this on this side. 4 sine cube x equal to, so sine cube x 1 by 4. Now it's very simple to integrate it, right? Now you can directly integrate it. 3 sin x, integration will be 3 cos x minus 3 cos x. Sin 3x minus sin 3x, so minus of minus plus cos 3x divided by 3 because x is multiplied by 3. So only thing is remaining is put out the upper limit minus lower limit. Clear? So this was about question number 37. The next one is 39. Question number 39, 0 to 1 sine inverse x dx. Okay, now sine inverse x. Again, this type of sum we had done in exercise 7.6. Integration by parts. I can take it as 0 to 1, 1 into sine inverse x dx. This will be u and this will be v. So now integration u as it is, integration of 1 is x minus derivative of this 1 upon root of 1 minus x square. Integration of 1 is x dx, right? So now just put integrate this. How will you integrate this? 1 minus x square. What is its derivative? Minus 2x, right? Derivative of 1 minus x square is minus 2x, right? So just multiply by minus 2, divide by minus 2. You get cancel plus Now, this is fx raised to minus 1 by 2. It's 1 by 2, but when it goes to numerator, minus 1 by 2. And this is f dash x, integration of fx raised to n, f dash x. Solve it, finally put the upper limit and subtract the lower limit from it. Clear? This was about question number 39. Next, question number 41. Dx upon e raised to x plus e raised to minus x. Let me check the limit, whether there is upper and lower limit or it's directly. Okay, there is no upper and lower limit. Okay, so how can you solve this? E raised to minus x, I can take it as 1 upon e raised to x. Clear? Now what should I do? Take the LCM. This e raised to x will jump to the numerator. E raised to x into e raised to x, e raised to 2x plus 1. Now you can see that you can assume e raised to x, right? If you assume let e raised to x equal to t, now when you will differentiate it, e raised to x dx will be equal to dt. Clear? So now when you replace it, e raised to x dx dt, that is equal to dt upon e raised to 2x plus 1 t square plus 1, right? So 1 upon x square plus a square. What is the formula for its integration? 1 by a, tan inverse x by a. So use that formula, right? See here there is no upper and lower limit. So finally after that you have to replace the value of t. Instead of t, you have to replace it with e raised to x. Clear? So this was about question number 41. Now, the last sum for today, that is question number 42. Integration of cos 2x sin x plus cos x whole square. Okay, now just think about it. How will you solve? It's not sine square x plus cos square x, it's sin x plus cos x, right? And in numerator it's cos 2x. So now see here, what is the formula for cos 2x? 2 cos square x minus 1, will it be useful? No. 1 minus 2 sin square x? No. But the third one, cos 2x equal to cos square x minus sin square x. See how it will be useful. This will be cos square x minus sin square x sin x plus cos x whole square dx. So now what is cos square x minus sin square x? Cos x minus sin x cos x plus sin x sin x plus cos x whole square dx. So now you know this, you are using this formula a square minus b square, a minus b, a plus b. And here also denominator have the same thing, cos x plus sin x. So these will get cancelled. Now, simple. What is derivative of sin x? Cos x. What is derivative of cos x? Minus sin x. So this is f dash x upon fx dx. It will be log of fx. So just solve it. Today the answer is clear. Log of sin x plus cos x plus c, right? So this will be log of sin x plus cos x plus c. Don't forget to put plus C in indefinite integration. Clear? So this was about question number 42. Okay. So you do one thing, just note down all these questions. Okay. Use the hint which I had gave you today and solve it completely by your own. So just note down this question. Okay. So that's it for today. Okay, we have taken two parts of exercise 7. Still, there are many some remaining. So, we will take again 2 or 3 video lectures to complete that exercise. Clear? But today, we will stop here. Thank you.